Now, for those of us who are not, into that field, what would you say? What is aging then actually?
Right. So, and you're quite right to ask that question early on in our discussion, because if you ask 10 people what aging is, you'll get about 10 different answers. It's ridiculous. This is the thing that's been the number one preoccupation of the human race ever since the beginning of civilization, and we still can't agree on a definition of it. Um, but anyway, so the definition that I like to use is as follows, and this definition is designed not only to be accurate, but also to demystify aging and help people to understand that it's not this God-given mystery that you said earlier. Um, so I say aging is the combination of two processes: a process that goes on throughout life, even starting before we're born, and a process that kicks off late in life. The first process, the lifelong one, is simply the creation of various types of damage in the body at the microscopic level, the molecular and cellular level, that are consequences, side effects of what the body needs to do to keep us alive from one day to the next. So biologists use the word metabolism to describe that network of processes that keep us alive, and I use the word damage to denote these side effects. And the reason I call them damage is simply because the body is set up to tolerate a certain amount of those changes to the molecular and cellular structure and composition, but only a certain amount. And therefore, eventually that amount is exceeded, and we get to the point where the body starts to go downhill. That is the second process, where the damage is abundant enough to cause the pathologies of late life, the decline in mental and physical function that eventually kills us. So that's all that aging is, the combination of those two processes.
Yeah, so we're accumulating damage over time, and up to a certain extent, where it gets more and more critical. But what do you think? How much of it is actually determined by our genetics versus by our lifestyle?
So, of course, if we ask any question about the extent to which something is determined by genetics, then we have to define our question a little bit better than that. We have to say, are we talking about the differences between different people or different individuals of the same species, or are we talking about differences between species? So let's talk about differences between species, first of all. For sure and certain, there are big differences in longevity between different mammalian species, even without going beyond mammals. And that is absolutely overwhelmingly determined by genetics, by what genes people versus mice and so on are made of. If we look within a species, it's a good deal subtler. Um, First of all, we do find that there's quite a bit of variation in pretty much every species between different individuals. And that variation is partly genetic, and it's partly environmental, and it's partly just luck, to be honest. So
Mm.
it turns out that subtle changes in the level of certain micronutrients during pregnancy has quite an impact on basically how biologically old you are when you're born, and that stays with you throughout life. There are other things. For example, it's been shown that the longevity of mice is influenced heavily by where in the womb the mouse was sitting, because mice have litters, of course. They have um, several offspring at the same time. Um, so yes, so there are lots and lots of things, but it's not all genetic.
That's interesting. The other day I was discussing, around longevity and health span, no, not lifespan, but also health span with some of my friends. And, we were wondering, is actually your younger ages, from birth to, I don't know, 10, 18, 20, are you actually aging faster during that than if you're older? Because you're growing and then you stop growing and then other processes in the body, start to take place. Is it
Yeah,
like accelerated aging in the young ages? How is it?
that is pretty much the case, yes. And actually,
Uh-huh.
I mentioned already prenatal life, before you're born. That's where it goes fast. Aging goes fastest of all. The reason really is because during the early parts of life, we are, as you say, growing. In other words, there's a lot of cell division happening. Um, Cell division is a risky process. It involves replication of DNA, for example, and that can be error prone. Now, that means that the faster you do it, the more errors are going to accumulate because, of course, the cell has a whole bunch of systems for detecting and correcting those errors, but those systems take time. So sometimes you will have a kind of, some damage to the DNA, for example, that happens, and it's possible to repair it, but after it has gone through a round of DNA replication, it becomes more difficult to repair it, maybe impossible. So rapid cell division is definitely bad for you. And in fact, this is probably the main reason why in some species, such as mice and dogs and horses, we see that smaller individuals live longer. In other words, basically individuals that grew more slowly.
Interesting. Yeah, very interesting. Do you believe there is a natural limit to human lifespan then?
Oh, of course, but it's irrelevant because the
Mhm.
definition of a natural limit is how long one can live in the absence of medicine, right? And we're not talking about the absence of medicine. So absolutely,
Mm.
yes, there is a lower limit to how rapidly these various types of damage that I mentioned will be generated by the body, below which, would be incompatible with being alive, with staying, with actually continuing to breathe and have a heartbeat and so on. Um, and then similarly, there's an upper limit to how much damage the body can tolerate before it starts going downhill and how far downhill it can go before it dies, right? So all of those things vary a little bit from one person to the next or from one mouse to the next, but they only vary within a certain range. And therefore, yes, there is absolutely a natural limit, but it's irrelevant because we have medicine.
Yeah, interesting. Interesting. So, um, okay, when we say aging is a process of, accumulating damage, for example, by, cellular division, and there might be, it's not a discrete process like it works or it doesn't, 0 or 1. There is some probability that some failures are introduced over time. Um, so yeah, we could say, sure, if you want to slow down aging, well, okay, we understand maybe it's just accumulating less of that damage. But reversing aging is a different game. Huh? How would you explain the idea of reversing aging to someone that's hearing about it for the first time?
Yeah, so that's a very apposite question. In fact, when I first started to put forward these ideas about reversing aging, it took several years for my colleagues in the expert community to really understand what I was saying well enough to say that I wasn't talking complete nonsense. It was assumed that reversing aging would necessarily be much, much harder than slowing aging down. And I pointed out, and eventually people understood what I was saying, that no, that's not the case because reversing aging means putting the body into a state that has less damage than it had before you started, right? Before you started your treatment. But that does not need to occur by reversal of the process that created damage. You can eliminate damage by other means. In the same way that in a car, for example, there's this thing called rusting that happens. That's definitely
Mhm.
the accumulation of one type of damage, right? Now, you don't need to understand the chemistry of rusting or to reverse the chemistry of rusting in order to get rid of rust. You can just scrape it off, right? And, repair the car that way. And of course, this kind of thing works. The reason we have cars that are 100 years old today that are working every bit as well as when they were built is because preventative maintenance, if it's comprehensive enough, transcends all of the second process, the process that kicks in when there's too much damage, like the doors falling off or whatever. So it's exactly the same. In this case, we're talking about not reversing the process of damage creation, but rather removing damage that has been created by whatever process. And the business of not needing to understand is really important here. This is not something that basic scientists find it easy to get their heads around. For them, comprehension is the goal for its own sake. Whereas for a technologist like myself, it's all about knowing enough to be able to manipulate the system that you're studying, right? If for a basic scientist, there is the concept of knowing enough doesn't compute. Um, and so so the idea here is excuse me. The idea here is to develop various techniques for removing damage from the body, and that constitutes de facto reversal of biological aging. But let's call it not reversal of aging, but rather reduction of biological age, because that's a better way of saying it.
Yes, yes. I was just about thinking the exact same thing, because if you talk, or if we would talk about the reversal of aging, what does it actually mean? Because we're not reversing to zero. That's obviously not the maximization that we're after. We don't want to, reverse back to stem cell, of course. So, but what is it about removing of damage? You said, but to what extent?
Yeah.
Because
So we can
uh,
actually
yeah.
remove damage to the extent of going back to age zero. It's just that what we
Mhm.
don't do is reverse development. During the first, let's say, 20 years of life, we're going through a programmed process of growth and maturation and so on that leads to eventually becoming an adult. And after that, basically nothing happens in terms of development. The only things that happen thereafter are the accumulation of damage, which eventually, as I say, causes things to go wrong. Now, that damage has been accumulating silently, harmlessly, during the first 20 years in parallel with development. The reason it was harmless is because it hadn't yet reached the level that is bad for you, that kicks off the pathologies of late life. And of course, it doesn't reach that until middle age or whatever. But no, so the idea is we can reverse damage all the way, in principle. It's just that we would not do anything to development.